In Module 12, Section 2, we will discuss solving quadratic equations by using the quadratic formula. Another technique for solving quadratic equations is to use the quadratic formula. This formula is derived from completing the square of a general quadratic equation. A quadratic equation written in standard form, ax squared plus bx plus c equals 0, has these solutions. And below, this is called the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's try a few examples. We want to solve 3n squared plus n minus 3 equals 0 by the quadratic formula. First, we find our a, b, and c value. A is the number in front of n squared, 3. B is the value in front of n, 1. And c is the constant, negative 3. Once we find a, b, and c, we write the quadratic formula. N equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Once we write the quadratic formula, we're going to plug into the quadratic formula. So we have n equals negative b, so negative 1, plus or minus the square root of 1 squared minus 4 times a, which is 3, times c, which is negative 3, all divided by 2 times a, or 2 times 3. As we continue to clean up, this becomes negative 1 plus or minus the square root of 1 squared is 1. Negative 4 times 3 times negative 3 will be a positive 36. All divided by 2 times 3 is 6. We continue to simplify underneath the square root. We have negative 1 plus or minus the square root of 37, all divided by 6. Because 37 is a prime number, these will be our answers. N equals negative 1 plus square root 37, all divided by 6, or negative 1 minus square root 37, all divided by 6. Let's try another example. 11n squared minus 9n equals 1. We want to solve that by the quadratic formula. Before we can solve, we have to have everything on one side of the equation equal 0. So we subtract 1 from each side. That gives us 11n squared minus 9n minus 1 equals 0. Now we can find a, b, and c. So from the equation, we have a equals 11, b equals negative 9, and c equals negative 1. Let's write the quadratic formula. If we write that every time, we should be able to remember it by the time we test. So negative b plus or minus b squared minus 4ac, all divided by 2a. Plugging in gives us negative 9, or the opposite of negative 9, plus or minus the square root of negative 9 squared minus 4 times a, which is 11, times c, which is negative 1, all divided by 2 times 11. We begin simplifying now. We have the opposite of negative 9, or positive 9, plus or minus the square root of 9. Negative 9 squared is 81. Negative 4 times 11 times negative 1 is a positive 44. All over 2 times 11 is 22. We continue to simplify underneath the square root. So this becomes 9 plus or minus the square root of 125 all over 22. Now we know that 125 is not a perfect square, so we would try to simplify the square root as much as possible. Let's go to the next slide to do that. Remember, in the last step, we had 9 plus or minus the square root of 125 all over 22. To simplify a square root, we first find the prime factorization of the number underneath. 125 is 5 times 25, which is 5 times 5. When we want to simplify a square root, we're looking for two identical factors. When we have two 5s, we can circle to form one group with one 5 left over. So this will become 9 plus or minus 5 square root 5, all divided by 22. And remember, we use the plus sign and the plus or minus sign for the first solution, the minus sign for the second solution. Let's try another example. Here we have 1/8x squared plus x minus 5 over 2 equals 0. And we want to solve this by the quadratic formula. The best way to start is to eliminate the fractions. To do so, we find the least common denominator of all fractions involved. And the LCD here is 8. Once we find that, we multiply every term by 8 on both sides of the equation. So let's write down what that would look like. We have 8, or 8 over 1, times 1/8 x squared, plus 8 times x, or just 8x, minus 8 over 1 times 5 over 2, equals 8 times 0, which is 0. As we multiply our fractions and simplify, this will give us x squared plus 8x minus 40 over 2, which is 20, equals 0. We now have a quadratic equation in standard form. A equals 1, B equals 8, and C equals negative 20. We take those values and plug them into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in and see what we get. Negative b, so negative 8 plus or minus b squared, or 8 squared minus 4 times a is 1, times c, which is negative 20, all divided by 2 times 1. This becomes negative 8 plus or minus the square root of 8 squared is 64. Negative 4 times 1 times negative 20 is a positive 80. All divided by 2 times 1 is 2. We continue to clean up underneath the square root. Negative 8 plus or minus the square root of 144 all over 2. Let's go to the next slide and continue to break this number down. We see that 144 is a perfect square, so we take the square root, and that gives us negative 8 plus or minus 12 over 2. And now we have two separate equations. Negative 8 plus 12 over 2, and negative 8 minus 12 over 2. Let's solve each. Starting with the plus sign, negative 8 plus 12 is 4. 4 over 2 is 2. That's one solution. Negative 8 minus 12 is negative 20, and negative 20 divided by 2 is negative 10. Now we have our two solutions. Let's try another example. We want to solve x times x plus 6 equals negative 30 by the quadratic formula. So we begin by distributing our x on the left-hand side. That gives us x squared plus 6x equals negative 30. We then add 30 to both sides so we can have a quadratic equation in standard form. And we're left with x squared plus 6x plus 30 equals 0. So now we can find a, b, and c. A equals 1, b equals 6, and c equals 30. We plug those values into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's plug in and see what we get. This becomes negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 30, all divided by 2 times 1. As we continue to simplify, this becomes negative 6 plus or minus 6 squared is 36, minus 4 times 1 times 30 is 120. All over 2 times 1 is 2. So we want to continue to simplify underneath the square root. And we will get negative 6 plus or minus the square root of negative 84 all over 2. So we subtract 36 minus 120, and we get negative 84. Let's take this to the next slide and continue to simplify. Negative 6 plus or minus the square root of negative 84 all over 2. Remember, anytime you have a negative underneath the square root, we pull the negative to the outside, or we just rewrite it as an I. So now we have negative 6 plus or minus I square root 84 over 2. 84 is not a perfect square, but that doesn't mean we can't simplify. So we make the prime factorization for 84. 84 is 2 times 42, which is 2 times 21, which is 3 times 7. We have a pair of 2's that we can pull out. So this becomes 6 plus or minus 2i square root of 3 times 7 is 21 all over 2. Now at this point we need to notice that the first term in the numerator and the second term in the numerator have a factor of 2 in common. So we factor out a 2, and that leaves us with negative 3 plus or minus I square root 21 over 2. The common factors of 2 in the numerator and denominator cancel. So our new two answers, negative 3 plus or minus I square root 21. And remember, this represents negative 3 plus I square root 21 and negative 3 minus I square root 21. Those are the two solutions. Let's try a word problem. Bailey's rectangular dog pen for his Irish setter must have an area of 300 square feet. Also, the length must be 50 feet longer than the width. Find the dimensions of the pen. So first we set up the equation. We'll set x equals the width, and we're told that the length must be 50 feet longer. And so the length will be x plus 50, just like the diagram shows us. X and x plus 50 are the dimensions. Remember, the area of a rectangular pen or a rectangle will be area equals length times width. And so if we plug in the information we know the area is 300. So 300 equals length we called x plus 50. Width, we said that was x. So we distribute the x inside parentheses, and we have 300 equals x squared plus 50x. We want our quadratic in standard form, so we subtract 300 from each side. We're left with 0 equals x squared plus 50x minus 300. So at this point, we can recognize that a equals 1, b equals 50, and c equals negative 300. We take this information and plug it into the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, let's begin to do this with the room we have left on this slide. So this becomes x equals negative 50 plus or minus the square root of 50 squared minus 4 times a, which is 1, times c, which is negative 300, all over 2 times a, or 2 times 1. So make sure you write that down. Let's go to the next slide and continue to simplify. So this will become x equals negative 50 plus or minus 50 squared is 2,500. The next piece that was underneath the square root was negative 4 times 1 times negative 300, which is positive 1,200, all divided by 2 times a, which is just 2. At this point, we continue to simplify underneath the square root, and we get x equals negative 50 plus or minus the square root of 3,700 all over 2. 3,700 is not a perfect square, but it can be factored, so we write its prime factorization. And remember, you can use a factor tree if you need to. 2 times 2 times 5 times 5 times 37 would be the factorization. So we take out our pair of 2's, our pair of 5's. 2 times 5 is 10. And this will become x equals negative 50 plus or minus 10 square root 37, all divided by 2. Just like in the last example, we have at least a common factor of 2 in the numerator that we can cancel with the denominator. So this becomes, if we cancel everything by 2, 2 goes into 2 once, 2 goes into 50 25 times, 2 goes into 10 5 times. This is negative 25 plus or minus 5 square root 37 all over 1, or we can just ignore the denominator at this point. Remember, we just solved for x, and we said that x was the width. To find the length, we need x plus 50. So we take the expression we just found, at negative 25 plus or minus 5 square root 37, and we add 50. Now, because we had 2 answers, we don't have 2 widths. If we were to put each answer inside a calculator, we would find that the negative 25 minus 5 square root 37 would not be a good answer. And so we are only concerned with the plus sign. We're not going to use the minus sign in the answer. So we plug in the expression that did work into the expression for the length. So x is negative 25 plus 5 square root 37 plus 50. We combine like terms, the 50 and negative 25, and we get positive 25 plus 5 square root 37. Let's try another example. Here we're told that a ball is thrown downward from the top of a 100-foot building with an initial velocity of 17 feet per second. The height of the ball after t seconds is given by the equation h equals negative 16t squared minus 17t plus 100. How long after the ball is thrown will it strike the ground? So we start with this last piece of information, striking the ground. Something strikes the ground, its height is 0. So we replace the h with a 0, and now we have an equation in standard form. 0 equals negative 16t squared minus 17t plus 100. At this point, we can recognize A, B, and C. A equals negative 16, B equals negative 17, and C equals positive 100. We take those three values and plug them into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So plugging in will give us t equals negative b, or negative 17. It gives us a positive 17 plus or minus the square root of negative 17 squared minus 4 times negative 16 times c, which was 100, all divided by 2 times negative 16. We can continue to simplify, and if we do, we will get t equals 17 plus or minus the square root of, or 17 squared is 289, 4 times 16 times 100 will give us 6,400, and since we had two negatives, that becomes positive, all divided by negative 32. So let's go to the next slide and continue to simplify. If we simplify underneath the square root, we have t equals 17 plus or minus, we had 289 plus 6,400. That will give us 6689, all divided by negative 32. Now at this point, we have two answers. We have 17 plus square root of 6689 over negative 32. And let's say the direction said it wanted an approximate answer. We would take the plus sign, we would put this expression into the calculator, and we would get the approximate value of negative 3.1. Now if we use the minus sign, 17 minus the square root of 6689 all over negative 32. We put this expression in the calculator, and we get the approximate value of 2.0. Remember, we're talking about the time it takes to fall from the sky down to the ground. We cannot have a negative value for time. So the only value that makes sense here is 2 seconds.